All right, so look, iron right here, okay, is a transition metal. Everybody understand that? Iron is right here on the periodic table. It's in that D sublevel section, so it's a transition metal. Iron can have a couple of different charges, okay? Sometimes you will see iron with a positive 2 charge, and sometimes you'll see it with a positive 3 charge. And here's the reason, okay? I'll give you a brief explanation for iron having a positive 2 or positive 3. It can form a positive 2 charge because iron can lose that 4s sublevel, okay? And that would give it a plus 2 charge. Now, how many electrons can fit in the D sublevel? In the D sublevel, how many spaces do you have? 10. What's half of 10? 5. The next best thing to having a filled sublevel is having a half-filled sublevel. So if you look, how many electrons does iron have in its D sublevel? 6, right? Okay, 1, 2, 3, 4, 5, 6. It's the 6th element over. Well, sometimes iron will lose the 4s electrons and it'll be a positive 2. Sometimes the iron will lose the 4s electrons and 1 electron out of the 3D, so that D sublevel will be half filled, and that'll give it a plus 3 charge. When that happens, it's going to donate 3 electrons to whatever anion it's bonding with. Okay, so that's why iron can have more than 1 charge. So in this case, iron is bonding with nitrate, okay, NO3. Now we have to do a little bit of work here to figure out what the charge is on iron. But first off, what's the charge on the nitrate? Look at your table. Nitrate. What's the charge? -1. How many of them do you have? You have 3. So that's 3 -1s, which gives it a total negative charge of -3. So what's the charge on iron? Positive 3, right? You see that? Okay. Look, guys, they have to cancel each other out. So if you have 3 -1s, that adds up to a -3, right? So the iron has to be positive 3 because there's only 1 of the iron. You look at the formula. Okay? So what this means is that you're going to write the name iron, and does everybody know your Roman numerals? Like up to 6? Yeah. So iron, you're going to put a 3 right there. So iron 3, that 3 indicates the charge on the iron. So iron 3 nitrate. You just write the name of the anion that comes after it. The 3, so any Roman numeral is always going to apply to the cation. So like if you look down here, you see a lot of these Roman numerals down at the bottom. They all apply to the first element, not the second. It's always going to be the first element. All right. Now, look right here at number 3. What is Ti? Titanium. Now, titanium is also a transition metal. What is the charge on bromide? Br? Right here, it's -1. And how many do you have? 3. So that's 3 -1s. So that's a -3. So what's the charge on titanium? That also has to be +3. So titanium 3 bromide. Okay? Titanium 3 bromide.
So that 3 applies to the bromide?
No, the 3 applies to the titanium.
Then why is it not by the titanium in the thing?
It is. It's right here.
No, in the other.
Oh, you're talking about right here. So this 3 right here tells me how many bromines I have. Okay, and look, I need you guys to listen to this, and I need you to hear it. Okay, the anion's charge is always the same. The cations are the only ones that can have multiple charges. So the Roman numeral always applies to the cation, and it's really only going to be for the ones that are transition metals. Like right here, potassium chloride. Is potassium a transition metal? It's right here. So no, it's not. So potassium always has a positive 1 charge. When I'm talking about these ones with multiple charges, I'm only talking about these ones right here. Okay? All right. Let's look at Cu3P. Okay, what's Cu? Copper. Copper cup. Okay? Now, this one's a little bit trickier because the number is actually on the cation, but you still have to look at the anion. What is the charge on the phosphide ion? P. P. Right here. It's a -3 charge. Does everybody understand that? Okay? You got to be able to look quickly at the periodic table and be able to figure out what the charge is just by looking at the group. Okay? So phosphide is in group 5, so it has a -3 charge. Well, look. There's 1 phosphorus, 3 coppers. So what does the charge have to be on copper to be able to balance out the phosphorus? Tanner's got it. It's got to be a +1. Does that make sense? Because look, you have to have 3 +1s to balance out 1 -3. So this is going to be copper 1 phosphide. Okay? And, all right, I'm going to give you this tip. This is not something that you have to do, but some people have found this helpful in the past. Sometimes it helps me. If you're unsure of what the charge is on the cation and you know it's a transition metal, this is one thing you can do. You know that there's 3 coppers. So if you draw yourself a little picture over here, sometimes it helps. So put 3 coppers and 1 phosphide ion. Well, I know that the charge on the phosphide ion is -3. So what does the charge on each one of these coppers have to be to balance that out? So if it's +1, +1, +1, that adds up to +3. That'll balance out the -3. Okay? Am I losing anybody?
I've been lost since the beginning.
Students, just a reminder that lockers are not available after 1st, 3rd,
All right.
and 7th bells. Please take what you need.
Let's
for
do
1st
some more
and 2nd,
examples here.
3rd and 4th, and 7th and 8th, all at the same time. Remember, keep moving. Get what you need and move on.
Well,
No
hold on.
congregating.
Okay. Now, I want to do one more example together, and then I'll let you do some on your own. Actually, I do want to do some with the formulas first, and then we can do some on your own. All right, number 5. Okay. There are 2 elements on the periodic table that you have to do this with, even though they're not transition metals. One of them is tin, Sn. Okay. The other one is lead, which is number 7. All right, and here's why. Tin and lead are right here on the periodic table. Sometimes tin and lead will lose just the p sublevel electrons and form a +2 charge. Sometimes they'll lose the p sublevel and their 2 s sublevel electrons and be a +4 charge. So it could be +2 or +4. So in this case, this is Sn, it's tin. And again, if you want to draw a picture, draw a picture. So there's 1 tin. So draw that. And there are 2 selenide ions, selenium. Well, what's the charge on selenium? -2. Well, if you have two negative 2s, that is a total of negative 4. So the 10 has to be positive 4 because you only have one of them. So this has to be 10, 4, and it's going to be selenide. Okay? Yes. Zan.
For titanium bromide, why would titanium lose 3?
All right. That is a good question. That one, I'm not sure why that one would lose 3, actually. That's a good question. You would think it would either lose 2 or 4. But say that again.
It would make sense to gain 3, so
Well, it's not going to gain 3. None of the metals are ever going to gain electrons. But you would think that titanium, I would have to look and see what the other charges are that titanium can make. But my guess would be that titanium can probably also make a positive 2 charge and a positive 4 charge. But that's just me speculating. So I'm never going to ask you to explain that though. Okay. All right. Now, does everybody know the Roman numerals up to 6? I'm going to write these up here at the top. So this is 1. 1 is just I. 2 is 2 I's. 3 is 3 I's. 4 is IV. 5 is just V. And then 6 is VI. So basically, once you get to 4, if the 1 is before the V, it's almost like it's subtracting from the V. The V is 5. And then if the I comes after the V, it's like it's added to it. So 1, 2, 3, 4, 5, 6. And honestly, 5 and 6 are pretty rare. Usually it'll be 1 through 4. But there are a couple of circumstances, like down here at the bottom, you have vanadium 5. So that's one example. And then chromium. Chromium here is a 3 charge, but chromium can form positive 6 charges. Okay? All right. Now, let's do a few at the bottom, and then I'll let you do some of these on your own. So this first one right here, number 11, you have chromium 3 phosphate. All right. Chromium is what? What's the symbol? Cr. And if it's chromium 3, that means a positive 3 charge. Okay? Now, I always have people that look at that 3 and they're like, oh, well, there's 3 chromiums. That's not true. The Roman numeral is the charge. It doesn't tell you how many. Okay? So chromium 3, Cr3 plus, and then what is phosphate?
Do you have a string? I need a
No, I
string.
don't. Phosphate.
PO4.
PO4. What's the charge? The charge is
-4. No,
negative 3.
I said that. Why did you look at me weird?
I didn't hear you. I wasn't even looking at you. Sorry, Grace. Okay, so that's PO4 3 minus. Now, same thing here. You crisscross the charge. However, these are the same charge, so they're just going to cancel out. So your final formula is going to be CrPO4. And that's it. Okay?
Why does the 4 go below?
Do you have a string?
Macy, can you tie it?
No, I need a string, okay? Just trust me.
A string?
Just trust me.
I don't have any string.
You don't have yarn or anything?
No, I don't think so. I have some fishing line.
That would actually work, I'm not kidding. That's
All right, give me just a second.
That is literally
Okay.
exactly what I need.
All right,
Fishing
let's
line?
do one more. So this is vanadium, which is V, and the charge is a positive 4. Okay, it's vanadium 4. What's carbonate?
Like in soda.
Not exactly the same thing.
Wait, so we have to know all this.
CO4
for-
negative 4. Yes.
CO3
So we have to know all this. for-
-2.
So
You
do
can
we have to
use
do
this.
on Tuesday or Monday?
This is going to be Tuesday. The Ionic is Tuesday.
Can we go back to the beginning of the first day?
We can do
Yeah,
that.
I
Okay.
still don't get this.
All right.
Wait, why is there 2? Shouldn't there be 4?
What? Where? Why is there 2 what?
Well, you need to add another one of those. Well, you need to add another carbonate to make it.
Don't we really?
Well, yeah. Okay. Hold on. You're getting ahead of yourselves.
Sorry.
Remember, ionic compounds, you crisscross the charge. So bring down the 4, bring down the 2. However, you are going to reduce. So it's not going to be V2CO3 4. You actually reduce it to VCO3 2.
Right.
Okay? You do need to put the carbonate, the CO3, you have to have that in parentheses. It's just like math. That 2 needs to apply to everything there, not just the oxygen.
When will we ever use this?
Today, Mr. Hanks.
Wait, 3.
No, I'm not saying that it gets
Wait,
you. I'm
But
saying
how does
that
4 and 2 cross?
Say it again.
Why do you have 3, 4? Why don't you just make that 7?
Divided by 2 equals 2.
Where? Here?
So confused.
Okay.
There's 4 carbonates, is that why?
Yes.
Okay.
But we reduce it. So there actually ends up being 2.
So carbonate is really just carbon oxide, carbon monoxide.
Well, carbonation that's in POP is carbon dioxide.
Carbon trioxide, that's what that is.
No.
Yes, it is. CO3. Carbon trioxide.
But it's an ion.
2.
But it's 2 nonmetals.
It is. It's covalently bonded. Okay? Yeah, that is something that you should understand.
Hey,
Why does my laugh sound like that? Sounds like
Okay? Listen.
Sounds like I'm having hiccups.
When you have a polyatomic ion, the ion itself will form an ionic bond. However, the polyatomic ion is actually covalently bonded together. Okay? So when you have like CO3, the CO3 is a covalent bond. The carbon and the oxygens are bonded together in a covalent bond. However, when it bonds to vanadium, that's an ionic bond. Okay? All right. I'm going to leave the rest for you guys to work on. And then when you have it,
Can I have some fishing line now?
raise your hand.
Can I have some fishing line?